Distinguished ladies and gentlemen, let us have a look at integrals of exponential functions. And basically, we shall integrate several exponential functions, and it is going to be easier, in fact. And this is one of the this is one of the exponential functions that we are going to integrate. I shall also write others as we continue to solve them. Ladies and gentlemen, how I wish that you could just subscribe to my YouTube channel. You could like, you could share and comment. Thank you. Let us have a look at this. This is the integral of exponential raised to power x. This is, the integral of exponential raised to power x with respect to dx. How do you integrate exponential raised to power x with respect to dx? How do you integrate this exponential function? Ladies and gentlemen, I'm going to show you on how we can integrate this exponential function with respect to dx. So integrating exponential raised to power x with respect to dx, this is what we shall do, ladies and gentlemen. That this is exponential raised to power x. So integrating this one, that is exponential raised to power x with respect to dx, is just we take the positive, not the positive, but we take the coefficient of this power, because this is x. The coefficient of x is just 1. So we shall take 1 times exponential raised to power x, then plus the constant of integration. So this is how you can integrate this function, this exponential function. That integrating this exponential raised to power x, you just take the coefficient of x, which is positive 1, then you multiply with the whole of this, that is exponential raised to power x, then we add the constant of integration, and finally that is our answer, that is exponential raised to power x plus a constant c. Now let us have a look at another example so that we get to understand more on integration of exponential functions. Now the second example is just the integral of exponential raised to power negative x with respect to dx. So how do you integrate this if we have a negative here? Ladies and gentlemen, it is just the same thing like what we have done here, that you take the coefficient of x, which is negative 1, then you multiply with the whole of this, that is exponential raised to power negative x, then plus the constant of integration. And therefore, we shall have negative 1 times this, we shall have negative exponential raised to power negative x plus the constant of integration. Now, ladies and gentlemen, we can have a look at the third example on integration of exponential functions. We can have a look at the third question, that integrate x squared exponential raised to power negative 2x cubed with respect to dx. This is the integral of x squared exponential raised to power negative 2x cubed with respect to dx. Now let us try to integrate this exponential function. Ladies and gentlemen, for us to integrate this, we can use the u substitution to integrate this exponential function. We can let u be negative 2x cubed. That is negative 2x cubed. We can let our u to be negative 2x cubed. So if we let our u to be negative 2x cubed, then basically du of dx, that is, if you differentiate negative 2x cubed, you shall get, in differentiation, you shall take the power and multiply with the whole of this, then you also less the power by 1. That is, we shall bring 3 backwards times negative 2x. Then the power, we shall reduce it by 1. And therefore, we shall have our, let me write it here, that our du of a dx will now be negative 6x raised to power 2. Now, I want to make du the subject of the formula. Making du the subject of the formula, we shall have du equals to, I shall multiply by dx on both sides. That is the left-hand side and the right-hand side. And we shall get negative 6x squared dx. Now, as you can have a look at our question, that we have x squared exponential raised power negative 2x cubed dx. So you can see that there is x squared and there is dx. So at this place you can see that there is x squared and dx. So let us make this the subject of the formula by dividing by negative 6 on both sides. So this one and this one simplifies, and therefore we have x squared dx as negative 1 over 6 du. This one is just the same as this. There is nothing that I've changed. Now, let us have a look at our question that integrate x squared dx is just 1 over 6 du. But we have exponential raised to power negative 2x cubed. So, but our negative 2x cubed, we had let it to be u. So we can say that exponential raised to power, this one is the one that I'm trying to look at, that we have exponential raised to power negative 2x cubed. But we have let negative 2x cubed to be u. Therefore, we shall have exponential raised to power u. I think we are together in that we are specifically looking at this, and we have let this power to be our u. Therefore, we shall have exponential raised to power u. This is what we have. So, we have x squared and dx as our negative 1 over 6 du. That is, times negative 1 over 6 du. Ladies and gentlemen, in integration, we cannot integrate a constant. So we shall bring this constant outside the integral sign, and therefore we shall have negative 1 over 6, the integral of exponential raised power u with respect to du. Now, let us integrate this. We shall have negative 1 over 6. What is exponential raised power u? Exponential raised power u is just exponential raised to power u, then plus the constant of integration. So as you can see, exponential raised power u is just exponential raised power u in integration. You can also see others like exponential raised to power x is just exponential raised to power x. So we can now continue with this, that we have negative 1 over 6 exponential raised power u plus c. This is our answer, but we had let our u be this one. Therefore, let us replace it the way it should be. We shall have our answer as negative 1 over 6 exponential, what is u? Negative 2x cubed, then plus the constant of integration. Now, ladies and gentlemen, that is how you can solve this exponential function using u substitution. Now, ladies and gentlemen, that is how you can solve exponential functions, and you can subscribe to my YouTube channel so that you cannot miss other questions concerning exponential functions on how you can also integrate other exponential functions, because I will also be uploading them. So thank you, ladies and gentlemen. How I wish just that you could subscribe to my YouTube channel, you could like, share, and comment. Thank you.